Hey guys, Mr. Milton here. Today we're going to look at trig word problems. At the end of this video, you should be able to differentiate between an angle of depression and an angle of elevation, and you should be able to set up and solve word problems involving trig. Okay, so we've already talked about solving for angles and side lengths in just everyday situations, I guess, if you're using trig every day. So now we're going to look at setting up word problems that involve it. Okay. As we look, I'd like for you guys to see the difference between angle of depression and angle of elevation. So in the picture above, angle 1 represents an angle of depression from the mountain to the hiker. Angle 2 represents the angle of elevation from the hiker to the mountaintop. The angle of elevation from the cabin to the person is represented by angle. Actually, let's talk about this a little bit. Okay, so as we look, a couple things that I want you to notice that this will help us with setting up our triangles, understanding what that angle of elevation and depression is. But one thing I want you to notice is that when we looked up, as we draw our triangle, if we're talking about an angle of elevation, notice that the angle of elevation is inside of our triangle. Okay. When we talk about angle of depression, notice that the angle of depression is outside of our triangle. Okay, but when we look at these angles here, we should notice that the angle of depression is here outside, where a lot of people will take it and make it inside of our triangle. So make sure that you remember that angle of depression is outside of our triangle. Moving on to the next thing, the angle of elevation from the cabin to the person is represented by, so as we look, okay, from the cabin, elevation looking up, from the cabin up, represented by angle 4. The angle of depression from the person to the cabin is represented by person to the cabin, angle 3. The dotted lines are all horizontal and therefore all parallel. Okay, that means that if we look at this, angle 1 and angle 2 and angle 3 and angle 4 are congruent to each other because of the alternate interior angles theorem. Okay, this is always the case. The angle of depression and the angle of elevation are congruent. Okay, just remember that our angle of depression is outside of our figure, outside of our triangle, where the angle of elevation is inside of our triangle. Okay. All right, so it says for each of these problems, draw the situation and then solve. Example number 1 says pilot sees a life raft at 26 degrees angle of depression. If the pilot's altitude is 3,000 meters, what is the plane's actual distance to the life raft to the nearest meter? So as we look at the image, we got a plane, airplane. All right. And so we see that the altitude of the pilot is 30,000 feet. Okay, it sees a life raft somewhere, so probably be over here somewhere, right? Okay. And it says that the angle of depression is 26 degrees. So as we look here, our angle of depression outside of our triangles here, and they want us to find the actual distance. So actual distance of the plane traveling would be this line, the straight line. Okay, when we talk about altitude, remember that we're talking about like a perpendicular height. Okay, so that makes it a right angle, so we can use our trig functions. So here they're asking us to find x with the information that they gave us. They gave us this angle is 26. So since this angle of depression is 26, the angle of elevation from the raft to the plane is 26 degrees. Okay, and so now we can look at labeling our triangles so that we know what function to use. From the angle that we're given, 26, we have the opposite side, and we want to find the hypotenuse. Okay, and SOHCAHTOA tells us that we're going to use sine. Sine of the angle 26 equals the opposite 3,000 over the hypotenuse x. Okay, and so we can find out what x is, multiply both sides by x. divide both sides by, so then we'll have x times sine 26 equals 3,000. Divide both sides by sine 26, and so I have x equals 3,000 divided by sine 26. Okay. So I got that down now. I'll use my calculator. 3,000 divided by sine 26 equals, all right, equals 6,843.5. 6,843.5. All right, and this direction for the problem told me to round my answer to the nearest meter, and so I should say, how far away is it? It is 6,844 meters. Okay, moving to the next problem. Number 2 says a surveyor stands 200 feet from a building to measure its height with a 5-foot surveying tool. Okay, the angle of elevation from the top of the tool to the top of the building is 35 degrees. How tall is the building to the nearest foot? So here's what we got. We got a surveying tool. It's 5 feet off the ground. Okay, and it's how far away from the building? 200 feet away from the building. So this way, 200 feet is a building, and has an angle of elevation. So as I look up here, from the top of this surveying tool to the top of the building is 35 degrees. All right, so I'm drawing my triangle in here. 90 degrees here, because we're talking about height. Height's always going to be that perpendicular height. Okay, this is 35 degrees inside here. It's angle of elevation, so we know it's inside the triangle. And we don't know what this is. I'll just call it X. Okay. And so now we have that stuff labeled out for ourselves. We can look at it and say, okay, we know the opposite, or we want to know the opposite side. And we know the adjacent side here is 200. So as we set up our function, we have opposite and adjacent, means we're using tangent. And so we'll say tangent from the angle that we're looking at is 35 equals opposite x over adjacent 200. And so we can find out what this x value is by solving, multiplying both sides by 200. 200 tangent 35 equals x. Okay, and my calculator, right? 200 times tangent 35. All right. And that equals 140.04. Okay. Okay, so 140.04, which to the nearest tenth is just 140.0, is x. Okay, a lot of people will put that in as an answer because we've done math and that's what we got. But remember here that we found out that this was 140. Okay, our surveying tool is 5 feet tall. And so when we talk about how tall the building is, remember we have to add that 5 feet to it as well. So our answer, actual factual answer, is 145 feet. And I guess we should say 0.0 since they told us to round to the nearest tenth. Number 3, a ship is able to determine that it is 600 yards from a sunken ship. If the angle of depression to the sunken ship is 50 degrees, how far does the ship have to travel to be directly over the sunken ship? Give your answer to the nearest yard. So here's what we got. We've got a ship. All right. And we see that this ship can say that it's 600 yards from a sunken ship. Okay, got that. Let me use a different color. So from a sunken ship, distance 600 yards. Okay. So we look over here. Okay. We want to be directly over it, so it'll be a perpendicular height. Okay. As we look, they tell us that the angle of depression is 50 yards, 50 degrees. Let me say that differently. The angle of depression is 50 degrees. Let me erase that. It's kind of in the way. All right. So the angle of depression is 50 degrees, and we're looking to see how far we have to travel in order to get right on top of it. Do that better. Okay, so as we look at our angle of depression, 50 degrees, remember that our angle of depression is outside of our triangle, and so we can use that and say that this is 50, so this must be 50. The other way that we can look at it is say that this is perpendicular, so this would be 40. Either way you did it, should work out. Okay, so as I'm looking at this, I want to know how far this traveling is, this travel. Okay, so as I go over, I should look at, this is the adjacent side from the 50 degrees I know. This is the hypotenuse of the 50 degrees I know. And so adjacent hypotenuse tells me I'm using cosine. So cosine 50 equals adjacent x over hypotenuse 600. Okay. Multiply both sides by 600. 600 times cosine 50 should give me my answer. And I'll do that in my calculator. 600 times cosine 50. And that gives me 385.67. Okay. And to the nearest yard, 385.67 is 386 yards. Okay. All right, just a couple more here. It says the Americans with Disability Act states that the wheelchair ramps have a slope of no greater than 1/12. What is the biggest angle of elevation to the nearest tenth of a ramp with this slope? So 1/12 is a slope. That's rise over run. So as we look at this, our run is 12. Our rise is 1, and they're asking us what's the greatest angle of elevation. So they're saying, hey, how far can this angle be? Okay, so with that said, labeling our sides, this is the opposite, this is the adjacent. Tangent x equals 1/12. To find out what x is, we'll use, remember, inverse tangent. So x equals the inverse tangent of 1/12. Calculator, do your job. 1/12 and find inverse tangent. And that gives me 4.76. Okay, so that angle to the nearest tenth would be 4.8 degrees. But as we look at it, because this is a it says it can't be greater than 1/12. If we do 0.8, we round it up, and we're going to make that greater. So we actually have to say 4.7. Okay, so this is one of those situations where you have to think through or think more than 5 to the sky, 4 to the floor. All right, one more problem. A pilot is ascending towards a runway at a 3-degree angle of depression. His current altitude is 2,714 feet above sea level. If the runway is 1,007 feet above sea level, how many miles is the plane from the runway to the nearest 100th of a mile? Okay, so as we look at this, we got a plane. It is 1,000. Our current altitude is 2,714 feet above sea level. Okay, so we're looking at the sea. And then it says that there's a runway that's 1,000 feet above the sea level. Okay, so it's trying to get on a runway. The runway is 1,000 feet above the sea level. Okay, how many miles is the plane from the runway to the nearest 100th of a mile? So as we look at this, draw this triangle in. Okay, they told us that the angle of depression was 3 degrees. Okay, so remember the angle of depression is outside of the triangle, so when we put it inside the triangle, angle of depression, angle of elevation from the runway to the plane's 3 degrees. We want to find out what this length is because they told us that it was 1,700 feet above the sea level at the runway, but then that our plane was 2,714 feet above the runway. But we really care about what this actual height is going to be, and that actual height is going to be 1,707 feet. Okay, so in this triangle, they're asking us how many miles is this plane from the runway, and so that's here. Talking about a plane's travel distance would be on this line. And so from our angle of elevation, we have the opposite and the hypotenuse. And so that means I'm going to use sine. And so I set this up as sine of 3 equals the opposite, 1,707 over the hypotenuse x. Multiply both sides by x to get it out of the denominator. And then divide both sides by sine 3. So x equals 1,707 divided by sine 3. 1,707 divided by sine 3 equals 32,616.19, so 0.20. All right, this is feet. The directions tell us to do this in the nearest hundredth of a mile. You'll notice that everything that they've given us up this point has been feet. And so we want to make sure that we do this to the nearest hundredth of a mile. And we can do that by dividing by or converting feet to miles. So in feet, there's 5,280 feet in a mile, 5,280. And so I'm going to divide 32616.2 divided by 5,280. And that gives me 6.177 or 6.18 miles. Okay. All right. And that is your word problems for SOHCAHTOA. See ya.